I'm Akhila, faculty in physics, Silver Hills High Secondary School. I welcome you to today's session of physics. We have already seen what is resistance, and also we have seen the factors on which resistance depend. Resistance of a conductor depends on the length of the conductor and area of cross section of the conductor. Combining all these factors, let's write an equation. That is, R is proportional to L and R is proportional to 1 by A, where L is the length of the conductor and A is area of cross section. So you can write it as R is proportional to L by A, or R is equal to rho into L by A, where rho is the constant of proportionality called the resistivity of the material of the conductor or specific resistance. Today we are going to learn about resistivity or specific resistance of a conductor. From this equation, R is equal to rho into L by A. If L is equal to 1 unit and A is equal to 1 square unit, in that case we can say R is equal to rho. That is, resistivity of a conductor can be defined as the resistance of the conductor of that material having unit length and unit area of cross section. Resistivity of a conductor depends only on the nature of the material of the conductor and physical conditions like temperature, pressure, etc. It is independent of size and shape of the conductor. Now let's see what is the SI unit of resistivity. We have the equation R is equal to rho into L by A, or RA by L is equal to rho. So from this equation it is very clear that the unit of resistivity is the unit of resistance multiplied by unit of area divided by unit of length. So unit of resistance is equal to ohm and unit of area is meter square divided by unit of length, which is meter. M and M will get cancelled and you can see the SI unit of resistivity is equal to ohm meter. So the SI unit of resistivity is ohm meter. Now let's see what is the dimensional formula of resistivity. The dimensional formula of resistivity is the dimensional formula of resistance multiplied by dimensional formula of area divided by dimensional formula of length. So first we have to find out the dimensional formula of resistance. Resistance is equal to potential difference by current divided by current. But potential difference is equal to potential or electric potential is equal to work by charge. The dimensional formula of work you have learned last year, which is equal to m L square T raised to minus 2 divided by the dimensional formula of charge is AT. So you will get this as m L square, T will go to the numerator, T raised to minus 3, A raised to minus 1. This is the dimensional formula of electric potential. Okay, now let's move to our previous equation, that is resistance is equal to potential difference by current. So the dimensional formula of potential difference is m L square T raised to minus 3, A raised to minus 1 divided by, you have current here and the dimensional formula of current is A. So let us write here A. So we have seen the dimensional formula of electric potential, which is equal to m L square T raised to minus 3, A raised to minus 1. Let us substitute that here. So you will get it as m L square T raised to minus 3, A raised to minus 1 divided by the dimensional formula of current is A. So the final dimensional formula you will get it as m L square T raised to minus 3, A raised to minus 2. Okay, Now this is the dimensional formula of resistance. Now comes the dimensional formula of resistivity. So dimensional formula of resistivity is dimensional formula of resistance, which is ml square t raised to minus 3 a raised to minus 2 into dimensional formula of area, which is L square divided by dimensional formula of length, which is L. One L and L will get cancelled and these two L will become L cube, and you can see m L cube t raised to minus 3 a raised to minus 2. This is the dimensional formula of resistivity. This is the dimensional formula of resistivity. Now, materials can be classified on the basis of their resistivity as conductors, insulators and semiconductors. Conductors are materials which have very less resistivity. Their resistivity range from 10 raised to minus 8 ohm meter to 10 raised to minus 6 ohm meter. Aluminum and copper have very less resistivity. Now, insulators have very high resistivity. Their resistivity is about 10 raised to 4 ohm meter. Materials like glass, mica, bakelite, hard rubber, etc. they have resistivity in the range of 10 raised to 14 ohm meter to 10 raised to 16 ohm meter. Then comes semiconductors. Semiconductors are materials which have their resistivity in between conductors and insulators, and they have resistivity in the range of 10 raised to minus 6 ohm meter to 10 raised to 4 ohm meter. Okay, so we have seen what is resistivity, we have seen the dimensional formula and also the unit of resistivity. Now next let us see what is conductance. Just like resistance is a hindrance to the flow of current through a conductor, conductance is the ease in flow of current through a material. Conductance is actually the reciprocal of resistance. Conductance is denoted by the letter G. So we have conductance is equal to 1 by resistance. That is G is equal to 1 by R. G is equal to 1 by R, where G is conductance and R is resistance. Now let us see what is the SI unit of conductance. SI unit of conductance is ohm raised to minus 1 or mho or Siemens. These are the units of conductance. The reciprocal of resistivity is what you call as conductivity. It is denoted by the letter sigma. So sigma is equal to 1 by rho. That is conductivity is equal to 1 by resistivity. Now let us see what is the SI unit of conductivity. We know that conductivity sigma is equal to 1 by rho. Also we have seen that ohm meter is the unit of resistivity. Ohm meter is the unit of rho or resistivity. So as sigma is equal to 1 by rho, you can say ohm raised to minus 1 or meter raised to minus 1 is the unit of conductivity. Or you can say mho meter raised to minus 1 is the unit of conductivity. Another unit of conductivity is Siemens per meter. Now let us start with a numerical problem. There is a wire of resistance R. It is stretched to n times its original length. So if n is its original length, and L dash is its length after stretching, then L dash will be equal to NL. And when the wire is being stretched, its volume does not change, volume remains the same. So you can write volume V is equal to the initial volume AL, which is equal to the final volume A dash L dash, where A is the area of cross section of the wire before stretching, A dash is the area of cross section of the wire after stretching, L is the length of the wire before stretching, and L dash is the length of the wire after stretching. Okay. So from this equation you can write A by A dash is equal to L dash by L. But here, from here you will get the equation L dash by L is equal to N. So A by A dash is equal to L dash by L is equal to N. This is another equation. Now let us write the equation for resistance before stretching, that is R is equal to rho into L by A. And after stretching, let me write it as R dash is equal to rho into L dash by A dash. Let us mark this as equation 1 and equation 2. Okay, now equation 2 by 1. You can see rho and rho will get cancelled and you will get it as R dash by R is equal to L dash by L into A by A dash. So this can be written as R dash by R is equal to L dash by L is N and A by A dash is again N. So you can write R dash by R is equal to N square or R dash is equal to N square R. So we have seen the new resistance R dash, that is the resistance after stretching, is equal to N square times the initial resistance before stretching. Now let us see another example. Suppose you have a wire of resistance R is equal to 10 ohm. You are stretching it to 3 times its initial length. So in the place of N you will have 3, that is L will be equal to 3, that is L dash will be equal to 3L. The new length will be 3 times the initial length. So the new resistance you can very well find it out using this equation, that is new resistance R dash is equal to N square, that is 3 square into the initial resistance is given to be 10 ohm, 10, which is equal to 9 into 10, which is equal to 90 ohm. Okay, with this we come to an end of today's session. Thank you and have a nice day.